Deep beneath our feet lies a hidden library. Its pages are not made of paper, but of stone pressed together by pressure and time. Each layer tells a story of vanished oceans, vast forests turning to coal, and sudden endings that reset life on Earth. In this episode, we test a bold idea. Can you find a vanished civilization without ruins? Only through chemistry. Would you recognize a civilization if only dust and numbers remained? If we could read those pages perfectly, they might reveal more than fossils and minerals. They might whisper about minds that shaped the planet long before us, minds that left no standing cities, only traces in chemistry, dust, and air. But if such traces exist, can we learn to read them? We do not need ruins to see that Earth remembers. A thin band of clay in Italy holds a sprinkle of iridium, a metal rare in our crust but common in space rocks. That thin band marks the day an asteroid ended the age of dinosaurs. 1 centimeter of soil recorded a world-changing event. If stone can remember one violent day, how much more might it still hold? Not the steel of a bridge or the glass of a tower, those crumble, but the gentle tilt of numbers in the air and ocean, the tiny patterns left when a species burns fuel, moves metals, and spreads new materials across the globe. And if some of those patterns are not natural, who wrote them? This simple idea has a name among scientists: the Silurian question. It does not claim hidden empires under the sea. It asks a cleaner thing. If an industrial civilization had come and gone long before us, would the planet show it? And would we recognize the signs? Time is a grinder. 1,000,000 years turns skylines to sand. 10 million years folds coasts into mountains. To be seen from deep time, a civilization has to write with atoms, not monuments. So we will look for 5 fingerprints: carbon, nitrogen, metals, synthetic molecules, and radiation. Start with carbon, the breath of the story we are living now. When we burn coal, oil, and gas, we add a flood of light carbon to the air. That shift shows up in ice, mud, and shells. It is like a signature written across the planet. We search for a sharp bend in the balance of carbon isotopes, a telling change in light versus heavy carbon that points to massive burning. If another species once burned ancient fuels at scale, a similar bend might still be there, waiting quietly in a core pulled from the sea floor. Is there already a bend we have misunderstood? The soil keeps a diary as well. Modern farming spreads fixed nitrogen across continents. That change leaves a global fingerprint in lakes and sediments. A short worldwide jump in nitrogen signals would look less like pure nature and more like policy. If others farmed long ago, they might have left the same kind of mark, subtle, but everywhere at once.
Then there are metals. Phones, cars, wires, turbines. Our lives run on copper and nickel, on aluminum and rare earth elements pulled from deep rock. Mining and smelting do not just move stones. They rearrange the chemistry of entire regions. Volcanoes spread elements in one way. Industry spreads them in patterns that look like trade, sharp, simultaneous, and global. Even after bright machines turn to reddish dust, unusual ratios and distributions can remain like a shadow of industry. There are also the things we invented that nature did not: plastics and other long-lived compounds. Even when they shatter into tiny pieces, their chemical fragments linger. Future readers will see a sharp layer of polymer residue that marks our age as clearly as a page break. Think of persistent plastic fragments and additives that nature rarely makes. If a similar layer once formed and then faded, would we notice it today? Or would we mistake it for some strange natural process? Finally, there is the loudest ink: radiation. Natural uranium deposits can act as slow reactors under special conditions, as the site at Oklo in Gabon shows. But the products of human-made splitting of atoms are different. Some isotopes do not occur in nature at all. One discovery of such isotopes in rocks older than our species, in the wrong place at the wrong time, would point, beyond volcanoes and lightning, to a hand that knew how to shape the fire inside the atom. Before we run away with the idea, let us be honest. So far, we have found no confirmed signs of any ancient industrial civilization on Earth. None. The cleanest story is still that we are the first. But asking the question changes how we look, and it sharpens our tools. It pushes us to search for signals that are short, worldwide, and coordinated, tucked inside the layers that mark big transitions in climate and life. Earth is both a notebook and an eraser. Coasts drown, deserts march, plates collide and recycle crust back into the mantle. A city may vanish in centuries. A continent can be sanded smooth in millions of years. What survives best are patterns that cover the whole planet. Shifts in the mix of gases, sudden changes in the way carbon moves through water and air, odd distributions of metals, and traces of materials that do not belong. These are not statues. They are patterns, quiet, stubborn, and testable. We are not searching for palaces. We are searching for patterns. Picture a team on a research ship lowering a pipe through 2 miles of ocean. Mud rises in a cylinder of time. You can see the ash from ancient eruptions as pale bands. You can see the slow drift of tiny shells. And in some sections, you can see the age we are building right now. Darker layers with soot, a jump in carbon, tiny plastic fragments, and little bits of metals used in engines and batteries. A future reader would not need to find New York or Tokyo to know we were here. The chemistry would tell the story all by itself. If we are this readable, how would a layer from someone before us sound? The chemistry is everywhere, in the snow of remote mountains, and the dust that settles on open seas, in the rings of trees and the shells of small sea creatures, in cave stalactites that grow the width of a coin over a lifetime. Our moment is global, and global moments are hard to hide. If we want to know whether there were others, we should hunt for their global moments too. Look for short worldwide peaks. Those are the bookmarks. This is why the question of before us is not a stunt. It teaches us how to read. It shows us which signals last and which vanish. It also helps us look beyond Earth. If technology tends to leave the same kinds of marks everywhere, then learning to spot those marks here gives us a map for Mars, for Venus, and for worlds around other stars. Let us imagine a few scenes. On Mars, a rover drills into layered rocks along the edge of an ancient lake. The core shows a short, sharp rise in light carbon, along with unusual chlorine-bearing compounds, amounts that are hard to make without factories. On Venus, high above the crushing heat, a balloon samples air and finds a mix of gases balanced in ways that look more like management than accident. Around a distant star, a planet's light carries hints of long-lived molecules that sunlight should tear apart quickly, unless something there keeps making them. We do not have proof for any of these scenes, but we can build tests for them. We can plan to taste rocks, to catch air, and to read the colors of faraway skies with patient eyes. If you want a full deep dive on how to detect industrial fingerprints on exoplanets, write EXO in the comments. For now, back to Earth's most puzzling pages. Back home, there are places where the pages of our library are especially interesting. The boundary where the dinosaurs vanish. The layers around the Great Dying, 252 million years ago, when most species went extinct. The start of the Great Oxidation, when oxygen first rose in the air. We have natural reasons for these changes. Impacts, giant lava flows, changes in oceans. Those are exactly the pages worth reading again with new tests. Do multiple global signals line up in a way that looks like industry? Do carbon, nitrogen, metals, and odd molecules all spike together for a short time and then fade? If not, the natural story stands. If yes, we keep digging. And if we reach for yes answers, the question changes from what to who. Think about how small our own chapter is. If human industry lasted 10,000 years, it would be a thin scratch on a very long timeline, a few heartbeats in 4.5 billion years. To be found by accident would be like finding one page in a library of 4 million books. That is why we do not rely on luck. We point our search at pages with big changes and ask if anything there looks coordinated, global, and brief. Not chance, but patterns. There is also a softer lesson here about humility. We like to picture ourselves as the first spark of mind on this planet. Maybe we are, or maybe we are one in a series of waves, each rising, each leaving a faint ring on the shore of time. Either way, the question puts our choices in a sharper light. The same signals that could reveal a lost civilization are the signals we are laying down right now. Our carbon curve, our plastics, our rearranged metals, our atoms split and scattered. We are writing our message, whether we mean to or not. We are writing want it or not. Pause and breathe. Most of the air you pulled in is nitrogen, stable and quiet. About a fifth is oxygen, a gift from ancient microbes. A small slice is carbon dioxide, now higher than at any time in human history. In that breath are molecules that once blew across fern forests, over warm inland seas, through smoke from early engines, and through the lungs of long-gone animals. If others were here long before us, a few of their molecules ride in with every inhale. The thought is haunting. It is also steadying. We are linked to everything that came before, whether or not there were cities in the deep past. Every breath is a footnote in a story of millions of years. What does all this mean for the story we tell on this channel? It means we chase wonder with evidence. As Brian Cox likes to say, human beings are capable of and responsible for miracles. One miracle is curiosity kept honest by measurement. We can love the mystery and still ask for proof. We can build a test and accept a no answer without losing the joy of the question.
If today's journey gave you something to think about, tap like. It sounds small, but it helps this conversation reach more curious minds.